Welcome to the presentation of the book entitled Sustainable Design for Renewable Processes. My name is Mariano Martin, and I'm Associate Professor of Chemical Engineering at the University of Salamanca. This book has been put together from my research group, but includes the contribution of many different colleagues from all over the world. Over the last weeks, we've been witnessing the discussions at the UN Climate Change Conference that encourage us to reduce the CO2 emissions towards a sustainable production system. The use of renewable resources presents a number of challenges to be integrated with the current production system. They are scattered and they are volatile. In addition, the traditional procedure for the design of processes can no longer be used since fails to address these challenges. We can no longer consider steady-state operation, as well as the economies of scale are not as important as before. The aim of this group is to prepare scientists, to prepare experts on the design of these processes for considering analysis, design, and evaluation of the use of these resources towards the production of chemicals and power. The book has been divided in 8 different sections, starting with the description of the resources and raw materials. The second section considers the design principles that presents the modeling as well as the solution procedures, including the environmental assessment. The third section includes biomass processing. Within this section, we consider different technologies such as gasification, hydrolysis, the circular economy towards the production of power and chemicals from waste, the added value products, and the design problem in considering the design of products, not only the processes, as well as the integrated biorefineries and the intensification strategies. The fourth section considers solar as energy source. We divided this section into concentrated solar power and PV. In terms of the concentrated solar power, we consider the evaluation of the entire system, from the collection of the solar irradiance, the production of power, the evaluation of different cycles, as well as the water energy nexus that is present in the cooling system of these facilities. In terms of the PV power, we consider also the production of the silicon that is the main raw material for these panels. We later move on to wind as raw material or resource that is captured using the design of turbines. We consider energy storage here, as well as introduce the concept of power to X to power, the use of power to produce chemicals and the use of those chemicals in order to store energy and later produce power. That presents several social implications that are covered in this chapter 2. We move on to geothermal energy, in which case we go further into the process and product design problem in terms of the selection of the heat transfer fluid and the evaluation of the thermodynamic cycle that produces the power. And we include safety considerations related to the toxicity, inflammability of those heat transfer fluids. The next chapter goes into the use of water, not only as a power resource, but also because seawater contains a number of ingredients, a number of salts that can be used for the production of different chemicals. The final section includes the integration of different resources and the methods in order to evaluate such as integration. And finally, we end up with energy storage. This book is aimed at PhD, but also master level students. And the idea is to provide a reference book for the analysis of these renewable processes.